Hi, Assalamualaikum warahmatullahi wabarakatuh. For today's video, our group, which is group 5, gonna present about rate. First of all, I'm gonna go through on our group task distribution for our group. Starting with me, I'm Johari. I will be explaining about introduction to rate and the history of rate. Next, for rate 013, will be explained by Dawi Adhar. For rate 456, will be explained by Alif Hazid. Next, for the pros and cons for rate 013 will be explained by Akmal Rahimi. Lastly, for the pros and cons for rate 456 will be explained by Khair Ikhwan. Moving on to the next part, what is rate? Rate is an acronym for redundant array of independent disks, which from the name itself clearly consists of multiple disks. So basically, RAID is a way of storing same data in different places, which this is in multiple hard disks or multiple solid state drives. Besides that, RAID also can be used to protect our data in case of a drive failure. RAID also have different levels, each individually with their own different purposes. Moving on to the RAID history. As you guys can see, these three pictures of these guys, they are the person who are responsible with the creation of RAID. As for the term RAID itself, it is definitely was coined by the three of them in 1987. However, in their 1988 technical report, which named a case for redundant arrays of inexpensive disks, they argued that an array of inexpensive drives could beat the performance of the top expensive disk drive of the current time. As for that, a RAID of array could be reliable than any one disk drive with the help of redundancy. Moving on to the next part, which is RAID terminologies. First is striping. Striping is a technique of segmenting logically sequential data, such as files, so that consecutive segments are stored on different physical storage devices. It is for easy understanding. It is like splitting the data flow towards multiple disks to increase the disk read and write performance. Okay, next for parallel access. Parallel access is a technique in which all member disks participate in every input and output operation at the same time. For this mirroring is a process of replication of onto logical disk volume onto separate physical hard disks in real time. This is to ensure continuous availability of the data. For easier understanding, the disk do copy the other disk in case of a data loss which due to a disk failure. Okay, next is independent access. Independent access is a technique in which all member disks participate independent so that the separate input and output requests can be satisfied in parallel. And lastly, for parity. Parity is used in RAID drive arrays for fault tolerance by calculating the data in two drives and storing the result in parity in the third drive. Moving on for the next presenter, which is Dawi Azhar.
There is a lot level of RAID that will be explained in this video. The first level of RAID is RAID 0. For RAID 0, it requires 2 or more disks. The data are stripped across the available disks. RAID 0 does not include any redundancy or backups. If it's just one of the disks fails, then all the data will be lost. Therefore, higher the number of disks used, higher the possibility of disk failure and data loss. However, the performance of RAID 0 is very high for both read and write. Next, we go to the RAID 1. For this RAID, it requires 2 or more disks. RAID 1 differs from RAID 2 through SIS in how redundancy is accomplished. RAID 1 achieves redundancy by the simple act of replicating all data, In other words, data are mirrored between two disks. In terms of data distribution, it is same as RAID 0. Data are stripped across the disks, but for this RAID, each logical strip is mapped to two physical disks so that every disk has its own mirror. If one of the disks are filled, there will be no loss of data because the other disk will have a duplicate copy. RAID 1 performance is higher than single disk for read, but similar to single disk for write. For RAID 2, it requires 3 or more disks. This RAID uses bit level stripping, which means instead of stripping the blocks across the disks, it stripes the bits across the disks. One group of disks are used to write the data, and another group is used to write the error correction code. This RAID uses Hamming error correction code and stores the information in the redundancy disk. For RAID 3, it requires 3 or more disks. This RAID uses bit level stripping, which is the same as RAID 2. This RAID uses multiple data disks and a dedicated disk to store parity. The disks have to spin in synchronous to store and get to the data. If one of the disks fails, the data will not be lost because RAID 3 can handle a single disk failure. The failed disk will be replaced and rebuilt, and the entire contents of the failed disk will be regenerated on the new disk. Consistency of the parity must be maintained for later regeneration. RAID 3 can achieve very high data transfer rates, and the performance of RAID 3 is the highest of all other RAID.
For RAID 4, we require 3 or more disks, where one disk will be used to store parity. Let's say we use 4 disks. If a disk fails, RAID 4 can handle one disk failure. We have to replace the failed disk with a new one, and RAID 4 will use the disk content parity to rebuild the data for the failed disk. RAID 4 performance is similar to RAID 0 for read and significantly lower than single disk for write. Next is RAID 5. For RAID 5, we also require 3 or more disks. Data is striped across multiple disks along with parity. If a disk fails, we will not lose any data because RAID 5 is designed to handle a single disk failure. We only have to replace the failed disk with a new one, and then RAID 5 would use parity information from the other disk to rebuild the data on the new disk. However, in special situations where two disks will fail at the same time in a RAID 5 setup, then all data would be lost, as it is not designed to handle two disk failures at the same time. In RAID 5, the equivalent size of 3 of these disks are actually used to store data, and the equivalent size of one of these disks is used to store parity. RAID 5 performance is similar to RAID 0 for read, and generally lower than single disk for write. The last one, RAID 6. For RAID 6, we require 4 or more disks. Parity is spread twice on all disks. The reason of this double parity is so it can handle two disk failures at the same time. When a disk failure occurs, the recovery method is the same as RAID 5. In RAID 6, if two disks were to fail at the same time, which is pretty rare, no data would be lost. The queue parity is needed, which is used to build a simultaneous equation. All we have to do is replace the failed disk, and then RAID 6 would use the double parity from the other disk to rebuild the data on the new drives. In RAID 6, the equivalent size of two of these disks are actually used.
Next, we are going to look for the advantages and disadvantages of RAID 1, 2 and 3. First of all, the advantages of RAID 0 is the input-output performance is greatly improved by spreading the input-output load across many channels and drive. Secondly, there will be no parity calculation overhead is involved in RAID 0, and then RAID 0 is very simple design and easy to be implemented. The disadvantages of RAID 0 is the failure of just one drive will result in all data in an array being lost. It is because RAID 0 provides no fault tolerance and redundancy. Other than that, RAID 0 should never be used in critical mission environment. Now we move to the advantages and disadvantages of RAID 1. Firstly, the advantages of RAID 1 is it can provide fault tolerance. It means that if one disk fails, the other one will automatically take over. So, continuous operation is maintained. Then, RAID 1 can also achieve high input-output request rates. Thirdly, it can increase read performance as different blocks can be accessed at once. It also is the simplest design of the RAID. The disadvantages of RAID 1 is it requires twice the storage space. This can prove that the cost is very expensive and it will lead slow write performance as data must be retained to 2 disks. Lastly, the space is wasted as same data is copied to 2 disks. Now we move to the advantages of RAID 2. We all know that RAID 2 is based on Hamming error correction code. Therefore, this level of bits can maintain the integrity of data. The second is speedy data error correction. It means that if there is a discrepancy, the lost data can be recalculated using the first or early checksum as a reference. Thirdly, the controller design of RAID 2 is simpler than RAID levels 3, 4 and 5. The disadvantages of RAID 2 is it is commercially unavailable. It is because it is inefficient. And then the transaction data rate is at the rate of a single disk at best with spindle synchronization. Lastly, the entry level cost is very high as it requires very high transfer data rate. Then we move to RAID 3. Firstly, the advantages of RAID 3 is high read and write data transfer. Secondly, this failure has an insignificant impact on throughput. Thirdly, it is a high efficiency. High efficiency means that low ratio of parity disk to data disk. There are 3 disadvantages of RAID 3, which are the controller design is very complex. Secondly, the transaction rate is equal to that of a single disk drive at best if spindles are synchronized. And the last one is RAID 3 is very difficult and resources intensive to do as a software RAID.
Okay, next, pros and cons for RAID 4, 5 and 6. The advantages for RAID 4 are very high read data transaction rate, low ratio parity disk to data disk, shows its high efficiency because the space is more efficiently used compared to RAID 1, since parity data in RAID 4 use lesser than mirroring disk in RAID 1. Then data block stripping, which facilitates simultaneous input-output requests. It does not require synchronized spindles or controller. The advantages are quite complex controller design, which is more complex than RAID 1. Then worse write transaction rate and write aggregate transfer rate. Difficult and inefficient data rebuild in the event of this failure. So if the dedicated parity disk fails, the data redundancy is lost. Then parity drives may lead to bottlenecks. And last one, slow random writes because parity must be separately written for each write. That's why it's slow. Then RAID 5 is very similar with RAID 4, but it has some different with some modification. The advantages, it has higher read data transaction rate with good random read performance and good sequential read and write performance. Then low ratio parity disk to data disk, good aggregate transfer rate, and it can tolerate the loss of a single drive, and it doesn't have bottleneck as in parity RAID 4 it has bottleneck. The advantages, it is more complex control design than RAID 4, difficult to rebuild in the event of a disk failure. As compared to RAID 1, it is easy to rebuild. Then parity calculation may slow down the system due to parity overhead. The random write performance takes a hit, and it can only handle up to a single disk failure, just single disk failure. Last one, RAID 6, it is better redundancy than RAID 5 because it used double parity blocks. RAID 5 it used just single parity block. Then it can sustain multiple simultaneous drive failures. So let's say if 2 drives fail, you still have access to all data even while the failed drives are being replaced. Then it provides for an extremely high data fault tolerance. The disadvantages, it more complex control design, and because rebuilding RAID array takes a longer time, and control overhead to compute parity addresses is extremely high. I think that's all from us. I hope you guys enjoy our video and understand the explanation about RAID. So that's all from us. Thank you. Assalamualaikum warahmatullahi wabarakatuh.